Hey everyone, this is Chiranjeevi, and in today's video we are going to cover the last behavioral design pattern, which is the state pattern. So the state is a behavioral design pattern that allows an object to alter its behavior when its internal state changes. The object will appear to change its class. So now what this means is if you can classify some of the object properties as a particular state and which is concrete, which means that the object remains in that state or not. So if you can classify a set of states for an object, you can use this design pattern to encapsulate them from each other and handle them separately. So the UML diagram for this state design pattern is pretty straightforward. You have a context which has a state. So you can see here that we have a context here. And this context has a reference to a state. Now the state over here has a handle method and it is an interface as well. So all these implementations for the state will provide the behavior for different types of states you are supporting in your system. So now we will take a look at set of steps which will help us to implement this state design pattern from scratch. The first step says that we need to create a state interface with transition to and display state methods. So let's quickly go over to our IDE and start coding these methods. So the first method which we want to support is transition to. So whenever we want to transition from a state 1 to state 2, we will be using this method inside an state to transition to a different state. Along with this state, we also want to support this handle method. So inside this handle method, for now, we will be using this display state methods. So you can extend this state interface to a number of methods you want to support. For the sake of simplicity, I'll be sticking to 2 now. So the second method is display state. So let's also define it here. And that's it. This is our state interface. Now we'll go ahead and create multiple different states out of this state interface. So for that, I am taking an example of an off state and an on state. So this example basically represents a light bulb, which is having two different states. It can be present in the on state and it can be also present in the off state. So whenever you want to toggle a state, what it will do, if it is in an on state, it will go transition to an off state, and similarly if it is in an off state, it will transition to an on state. So this is what I am trying to show you using this example through the state design pattern. So let's go to the on state and implement that. Now we are in the on state, so now we have to give the implementation for this on state. So before going that, we will also need the light bulb we will be storing the state to, show that this state can transition the state for this light bulb from on state to off state. In the constructor for this on state, we will take the light bulb reference and set it as a member. So this dot bulb is equal to bulb. Now, since this is a state interface implementation, we will also have to provide the implementation for these methods. So let's go ahead and quickly override these. And in the transition to method, what I'm going to do is I'll just say this dot bulb dot set current state to next state. Okay, so you might be thinking that what is this set current state? So we will be going ahead in the light bulb and defining this method. So let's quickly go to the light bulb and define this method. But before that, I would like to add a simple logging statement in the handle method, which is our display state method. So I will just say system.out.println light bulb is turned on. So this is it with the on state. Since this method is not defined, it's looking very ugly right now. So let's go ahead in our light bulb class and implement this method. So now we are in the light bulb class. We will also need to have a state to state mapping so that we can know that from which state we can go to which state. So for that, I will be storing a map here. So we will create a map of state and a state. And let me name this map light bulb state map. Now what this is basically storing is from one state where can I go to. So this will technically be storing the, if I am in an on state, I can go to off state, and if I am in an off state, I can go to on state. So that I don't have to create every time a new reference for transitioning state. Let's also store the current state for the light bulb. So let's name it current state and have a constructor which initializes all these things. So let's rename it. Okay. So now in this, let's create two states. One is called on state, and we pass this reference over here. The second one is called the off state. So we'll go to the same declaration and just rename the on state to off state. Now we have not defined our off state yet, that's why it's giving error. So let's ignore that for now and continue with our light bulb state map initialization. So light bulb. Now what we want to do is we want to add states to light bulb state map. So we'll say light bulb state map dot put, and we will pass the on state comma off state, which means that we can go from on state to off state. And similarly, we can also go from off state to an on state. So now our light bulb state map is in established state. So now we will go ahead and set the current state to a default state whenever this light bulb is created, which will be our off state. So now that's it with the constructor. Let's also provide a setter method for this state. Remember that on state is calling a set current state method on this light bulb. So we need to have a set current state method. So let's quickly go ahead and implement this method. And this will take a state and just set this current state to the coming state. And that's it. That's how we will change the state of this light bulb. Let's also have a method to display the current state behavior. Since we cannot access the state directly from outside, we need to use the light bulb to actually delegate its display state to the internal state. So we'll just say this dot current state dot display. And what this will do is this will just print a logging statement. If you remember, we have done something like this in this. So light bulb is turned on. So if the state is on state, it will show you light bulb is turned on. So now let's go to the light bulb again and see what we can add more. So everything is in place, but remaining one thing is there, which is if we want to toggle an state, we need to provide that functionality also. So if that toggle is being handled, so we will say that this dot current state dot transition to. So we want from the current state to transition to a new state, but how will we know that? How can we transition from one state to another? And just for this purpose, we have created this map which holds a state to state reference. So now if we pass the current state over here, we can get that from which state this state should transition to. So let's go ahead and do that. So light bulb state map dot get. So now we want to get the next state from which this state can be transitioned to perfectly. And this will return the next state which we can transition to. So this is what we have to do with this light bulb. Now let's quickly go ahead and in our off state method, let's quickly define all this method. So this off state will also be similarly like on state. So let me go ahead and copy all these things. And instead of on state, we'll just rename everything to off state. So light bulb is turned on, here light bulb will be turned off, and that's it. So this is what we have to do the setup for this off state. So now if you take a look at the steps I mentioned here to implement the state design pattern, this is what we have done right now. So we have created a state interface with transition to and display state methods, and this is the state what I was talking about. And we have provided two implementation for this interface. N belongs to the number of states you want to support. So in our light bulb example, there are only two states. The states are off state and on state. So we have provided two implementation for this state interface, which is the on state and the off state. Now, in the third step, what we have to do is we have to create a map of state to state where each entry denotes that you can go from state 1 to state 2. And now that's also we have done in our light bulb class. We are storing a map which tells us that from a state A whether I can go to state B or not. And now the only step which remains is we have to use this class to toggle and display state and do things on the transitioning state. So let's go ahead and quickly do it. So we have created our light bulb, we have created our state, and the only thing which is pending is to see this in action. So let's quickly go ahead and create a main method for this. So public static void main string arguments, and inside this let me create a light bulb reference. So I will say light bulb is new light bulb. This does not take anything in the constructor. What this will do is it will initialize the state map. Now if I do a bulb dot display state here, I should see that the bulb is in off state. So that's what our expectation is, because we set the light bulb's default state to an off state. Now let's go ahead and do a bulb dot toggle. And now if you remember, in the bulb dot toggle, it will get the next state from the map and set it to current state. So after toggling the bulb, we should see that the bulb should be in an on state. And as you can see, the bulb is in on state. So this is how the state design pattern helps you maintain different states in your program for an entity. So you can do it multiple times and your program will react to it. So light bulb has a particular state and it maintains and behaves on that state only. So whenever you see that you have a state which can be extracted out from a class implementation, you should go for this state design pattern. Whenever you have a set of states which you can transition from one and another, you should always look at this pattern. So that's it with the state design pattern. It talks to you about allowing an object to alter its behavior when its internal state changes. The object will appear to change its class, and that's what we are seeing here. The state member in the light bulb class is changing its class from off state to on state. So that's it guys with the state design pattern. I hope you have understood what state design pattern is and you can use these following steps to implement that from scratch. Thank you guys for watching my video, and I'll see you in the next one.